Good day, I'm Peter Foy, Senior Engineer with Ericsson Enterprise Wireless Solutions, and today I'm going to be showing you a demo and an overview of a solution from our partner Supermicro. They have developed a Jetson-based platform for Edge AI applications. So Jetson has a series of embedded devices. The brand new series is called Orin. There's three different families within this device series: the AGX, the NX, and the Nano. They have selected the NX series based on its performance at 157 TOPS and its power. So power performance, that was a sweet spot. That's why it was chosen. The AGX runs at 275 TOPS and the Orin Nano runs at 67 TOPS. So diving down a little bit deeper in the NX series, I'll go through the 16 gig. So again, the performance is 157 TOPS. The GPU has 32 tensor cores. The CPU consists of an 8-core ARM Cortex A78. It's a 64-bit machine, of course. The memory is at 16 gig and that uses the LPDDR5. Video encode, there's lots of opportunity for video encode ports for H.265 at different bandwidths at 60, 30 frames per second at 4K, and then at 1080p you have up to 6 inputs. And the video decode, H.265 as well. And then the power consumption on this device ranges from 10 to 40 watts. The demo I'm going to be showing you today, it will show the module running at 25 watts, and that gives you the dimensions of the module itself at 69.6 by 45 millimeters. So what's the Jetson box consist of? The module, of course, which we just covered, a carrier board, and the carrier board was actually developed by Supermicro. And then also the chassis. So the chassis can be wall mounted. You can place it on your desktop, of course, and it can also be DIN rail mounted. So the part number for this Supermicro Jetson box, it is fanless. It's ARS E103JONX. This is a compact fanless system again, running 157 TOPS. Interfaces, it has 4 PoE ports at 1 gig, 1 uplink port, 3 USB ports, 1 OTG or on-the-go USB port, 1 HDMI output, 4 output digital inputs and outputs, 2 COM ports, 1 isolated CAN bus, several M.2M key ports, and then the voltage range varies from 9 to 36 volts. Again, this is for industrial type applications, or so the operating temperature is between minus 25 and 60 C. And then again, that shows you the mounting options. So I'm going to show you 2 demos today. The first one's going to be a NanoOWL. The NanoOWL is an open vocabulary object detection network trained on a variety of image and text pairs. It can be used to query an image, just like we show here, with multiple text queries within each other. So, for instance, it shows here where you're detecting a person. It also sees the face and the nose. So it has the logic to actually do a multi-level text inference engine. So I'll give you show you an example of that. And then next I'm going to show you the Ultralytics, the YOLO, you only look once, a real-time object detection model. So I'll give you an example of that as well. So this is an open model that they provide. Now Ultralytics will do several other things for you. They'll train models for you. They'll implement the model based on what system you're using. In this case, they've implemented a model that's pretty simple to run on this platform, this Orin NX16. So let's take a peek at that. Okay, next let's show you the demo of the NanoOWL. I've already got everything loaded up here, so I'm actually running a container here that's already got everything preloaded for this inference engine. So, and there's also another tool that this uses as well, that this example uses, called AIO-HTTP, and it's a Python library that implements an asynchronous HTTP client server that runs on top of Python's async IO. So I'm using that as well. So let's go ahead and open up the demo here. You can see that I've got JTOP open here that shows you, how many of the CPUs are running, at what percentage they're running, and then if the GPU is running and what percentage it is being used at as well. So you see it's pretty low right here, right now, because we're not actually running the inference engine yet. And then also have a GUI open here that shows you the thermal power and the current temperature, and then also the current and voltage for each one of the power planes within the module itself. So this is running now, and it's actually going to show you through that AIO-HTTP. It's going to show you the results in a browser window. So you can see in my office here, I got some pretty interesting things we can take a peek at. So let's see if we can see an oscilloscope. Yep, picks that out. We got a Mickey Mouse there. Let's see about a Mickey Mouse. Thanks, Mickey Mouse, and the astronaut or Mickey Mouse. Let's see if we just look at the astronaut. Okay, whoop. It's getting confused between the astronaut and Mickey Mouse as well. What if we put an astronaut in space? Okay. So now we can get it to hone in on an astronaut in space. Still thinks Mickey Mouse is, and in space too. Anywho, probably need to do a little more training on the model there. But again, this is an example that's put out there, and it shows how much power you have with this NX16. So that's the first example. I wanted to point out one more thing before I close this example down. So while the inference engine is running, let's take a look at the power in the GPU. So you can see the GPU is up here running, between 50 and 99%. So taxing and using a lot of GPU is running at 408 megahertz. And you can see where the CPU cores are also, all of them are running. Just wanted to point that out before we move on to the next demo. Okay, the next example I'm going to show is the Ultralytics YOLO N11 model. So I've actually got that in Visual Studio Code already, got the code written up here. So we'll open it up. So we're going to use the YOLO model, and then we're going to actually read in a couple of images here. It's going to plot the results, and then it's going to show them on the screen and save the results to disk. So anyway, we can go ahead and get started here. I've already ran this, as you can see, but let's go ahead and run it again. So you can see the first image, it's found 3 persons or people and a bus. And in the second image, it's found 2 people and a tie. So let's go look at some of the statistics here. So the statistics were, 4 persons, 1 bus at 93 milliseconds. So The inference time here for pre-processing and then the actual inference engine running is 63 milliseconds. So that's pretty decent for this size of an image. Anyway, those are two quick examples of how you can use, computer vision and inferencing engines at the edge. Anyway, thanks for joining me today.